All right, let's take a look at the law of cosines homework, 6-2 homework. We'll go through the even problem, starting with problem 12. So our job here is to use the law of cosines to solve the triangle. So I'm going to start by drawing it. For problem 12, label it ABC. And so A is going to be 1.42, B is going to be 0.75, and C is going to be 1.25. And so I'm going to start with the biggest angle, and the biggest angle is going to be across from the biggest side, 1.42. So I'll start with angle A. To do that, we'll have the 1.42 squared by itself is equal to 1.25 squared plus 0.75 squared minus 2, 1.25. 0.75 times the cosine of A. Go ahead and plug that into our calculator, and you should end up with 0.58 equals the cosine of A. Let's go ahead and do our inverse cosine and end up with an angle for A. You get 86.7 degrees for A. So A becomes 86.7 degrees. All right, let me go ahead and erase this to clear some screen space. Next up, we want to go ahead and find either angle C or angle B. I'm going to go in order and find the next largest angle. That's going to be angle C down here. And now that I know an angle, I know angle A, I'm going to go to the law of sines because it's a little bit shorter. So we can say sine of 86.7 over 1.42 equals the sine of C over 1.25. And so let me plug that into my calculator. Sine 86.7 divided by 1.42 times 1.25, and I get 0.8788 equals sine C. I'm going to use the inverse to get rid of the sine, and I end up with 61 degrees, 0.50 for C. And now that we have two angles, finding the third angle is a simple matter of subtracting from 180 degrees. So we're going to say 180 minus angle A, which is the 86.7, minus angle C, which is the 61.50. Plug it in. We end up with 31.8 degrees for angle B. Let's move along. 18, we're going to do the same thing. We're going to solve for the triangle. Quick conversion here, 15 degrees and 15 minutes. We're going to go 15 over 60 to get 0.25, so angle C is really 15.25 degrees. And so let's draw ourselves a triangle, ABC. A is 7.45, B is 2.15, and angle C we said was 15.25. All right, let's go ahead and find our missing side first. C squared, little c squared, equals 7.45 squared plus 2.15 squared minus 2 times 7.45 times 2.15 times the cosine of C, which is 15.25 degrees. Plug it into our calculators. Let's see what we get. 7.45 squared plus 2.15 squared minus 2 times 7.45 times 2.15 times the cosine of 15.25, and I get 29.22 for C squared. Let's square root both sides and find C, and I get 5 0.41 over here for C. Side C, not angle C. All right, once we have that, we're all set up. We could do law of sines from here, which is typically faster than doing the law of cosines. So I'm going to do that to find, let's find the largest angle now, angle A. So sine A over 7.45 is equal to the sine of 15.25 over 5.41. Going to plug this in. Sine of 15.25 divided by 5.41 times 7.45, and I get sine of A equal to 0.36, and I'll do the inverse sine of that, and I get A is 21.24 degrees. All right, now we have to pause here for a second on that angle, because that angle seems awfully small right there, especially seeing as it needs to be our biggest angle, right? And so it's going to be bigger than 1520.25, which it is, but there's 180 degrees in a triangle, and we're in danger here of having B then be our largest angle. So we have to think to ourselves, is there another possible angle in here? And there certainly is. 180 minus 21.24 is our other possible angle. And we get 158.76. And so that's the angle we want to use. All right, let's subtract from 180. And we end up with 6.01 degrees for B. Okay, so we have to be careful and look at our angles and make sure that the largest side matches up with the largest angle. Remember, anytime we do the inverse sine, we get not just one, but two different angles. And so we have to be smart about which one to pick, which one to use. All right, moving on to 24. 24 is our next one in there. All right, first thing in here, they tell us that A is 40. They tell us that B is 60. And they tell us that side D, from here to here, D is 80. And so let's go ahead and solve for our angles. Let's find theta first. So we can say theta is the angle across from 80. So 80 is the number that sits by itself in the 80 squared. 80 squared equals 40 squared plus 60 squared minus 240 times 60 cosine theta. Plug this in. 80 squared is 6,400. 40 squared plus 60 squared is 5,200 minus 2 times 40 times 60 is 4,800 cosine theta. And so let's subtract 5,200. And we get 1,200 equals negative 4,800 cosine theta. Let's divide by 4,800, negative. And we get negative 1/4, negative 0.25 equals cos theta. Let's do the inverse. And we get 104 degrees for theta, 104.5. degrees in there. All right, the one thing that we know about the two adjacent angles in any parallelogram is that they add up to 180. So we can say 180 minus 104.5. And we get 75.5. That'll be our other angle. And we still need to find out C here. So we can do the law of cosines again. Oops, so where's the answer? 104.5 and 75.5. All right, so for C, C is going to be C squared equals, the two other sides are still 60 and 40, minus 2, 60 times 40 times the cosine of what angle is across from C? It's going to be this angle down here, which we decided was 75.5. So let's plug that in real quick. 60 squared plus 40 squared minus 2 times 60 times 40 times cosine of 75.5. And you end up with C squared being 3998.18. Take the square root of that to finish it, and you end up with 63.23 for side C. All right, problem 30 is what we're looking at. Determine whether the law of sines or law of cosines is needed to solve the triangle. Then we solve it. So it's giving you the information, letting you choose whether you want to go law of sines or law of cosines here. So A is 11, B is 13, C is 7. In this case, do we have an angle across from any of the sides? No, so we've got to go law of cosines. And so let's start by finding the largest angle here. So we want to go with B because it's across from the 13. So, sorry, B squared is 13 squared equals 11 squared plus 7 squared minus 2, 11, 7 cos of angle B. We're not sure what that is. 13 squared is 169. 11 squared plus 7 squared is 170 minus 22 times 7 is 154 cos B. So when I move stuff around, 169 minus 170 is negative 1 divided by negative 154. And then we're going to do the inverse cosine. So I got 0.006 equals cos B. I got B equal to 89.63 degrees. So from there, we can do law of sines, which is typically less calculation than the law of cosines. And now we know when we do the law of sines that all of our angles have to be smaller than 90. So we don't have to worry about the two angle problem that we get when we do the inverse sine. So I'm going to start with the next largest angle, angle A. So sine A over 11 is equal to the sine of 89.63 over 13. Plug them in. Sine divided by 13 times 11, second sine, and I get 57.79 degrees. And then to finish it up for angle C, what do we need to do? We need to subtract from 180. So 180 minus 57.79 minus 89.63. And let's see what we get. 180 minus that minus that. And I get 32.58 degrees. Alright, one more before we jump into the word problems, problem 36. And let's use Heron's formula here to find the area of the triangle. So Heron's formula, first thing we need to do is find the semi-perimeter, which means add them all up. A plus B plus C, 75.4 plus 52 plus 52 again. And I get 179.4. That'd be the perimeter. To be the semi-perimeter, I got to divide by 2. We get 89.7. Alright, so Heron's formula for area is S times S minus A times S minus B times S minus C. And so here we go. Square root of 89.7. 89.7 minus A is 14.3. 89.7 minus 52 is 37.7. And that happens twice because B is the same as C. And let's multiply them all together. And I get the square root of 1823102.896. So that's 1,823,102.896. Square root that. And final area on here is going to be 1,350.22. No units given in this problem. Alright, I'm going to pause it here and start the next video for the word problems.